Hey, so this is number 6 on this homework assignment, and again, what we're talking about is solving systems of equations using elimination. And as I look at this problem, there's several things that I could do. I do have both equations written in standard form. I see the ax plus by equals c. I could choose to either eliminate the x's, or I could choose to eliminate the y's. And it really doesn't matter which one I do. If I wanted to eliminate my y variables, I would multiply this top equation, both the left and right hand side, by a positive 3. The reason why I would do that is then I would have a negative 3y and a positive 3y. So the y coefficients would be opposites and cancel. Also, I could choose to just multiply the second equation by 2. If I multiplied the second equation by the number 2, then I could see that my x's would have coefficients of 4x and negative 4x. So they would be opposites and would cancel nicely. And multiplying by 2 seems a little bit, ever so slightly more simple than multiplying by 3, I guess. So I'm going to do that. I'm going to go ahead and multiply both sides of the second equation by 2. And when I do that, I notice that I do have two terms on the left-hand side. Both of those must be multiplied by 2. And the 10 over on the right-hand side of the equation must also be multiplied by 2. So I'm not going to go fast or go crazy here, but I'm going to go ahead and rewrite that second equation. As I multiply both sides of it by 2, it's going to become a negative 4x plus 6y, and that will equal 20. And in that top equation, if I multiply, well, I'm not going to multiply it by anything. I'm just going to rewrite the top equation. Rewriting the top one, it is 4x and then minus y, and that equals negative 5. So again, this linear combinations, elimination is not magic. What I'm doing is I'm taking, two things that are equal, and I'm adding it to two sides of an equation that are equal. So, and I show this all the time, but if I have, for example, 2 equals 2, those are equal things. Think about that as the top equation. And if I decide to add equal things to both sides of that, I could add 5. When I combine these equations, right, when I add them up, notice what I have. I've got equal things. I'm going to add equal things, and I get equal things. So this is kind of the justification for why this method of solving systems work. I have equal quantities, and on each side of it, I'm adding equal quantities, and I get equal quantities. And even if I was to take the original 2 equations and do that, I would get a third equation that would fit that situation, but it wouldn't eliminate one of my variables. And that's what I'm looking for, and that's what I have here. The x's will eliminate. When I add the 4x and the negative 4x, there's nothing left, 0x. If I add negative y and 6y, that's going to equal a positive 5y. And then finally, when I add negative 5 and 20, that will equal exactly 15. Dividing both sides by 5, we get that y equals 3. So we now have the value of y. And to find out what x is, we just pick either one of the 2 equations above and substitute that in and solve for x. I'm going to go ahead and pick this top equation, and I'll rewrite that. So that equation is going to become 4 times x minus y. Again, instead of writing y, we're going to write the value of y that we found. So we're going to write minus 3, and that equals the number negative 5. So 5x minus 3 equals negative 5. Now I'm going to go ahead and add 3 to both sides of this equation so that we get 4x equals, if I add 3 to negative 5, I'm going to end up with a negative 2. And then finally I need to divide both sides by 4. So when I divide both sides by 4, I'm using the division property of equality. On the left-hand side, we end up getting that x is by itself, so just a single x. On the right-hand side, we get the fraction negative 2/4, which does reduce to negative 1/2. So the solution to this system is x is negative 1/2 and y is 3.